Now coming to next problem. A gaseous mixture contains 40 mole percent N2, 60 mole percent C6H6 at 460 Kelvin and 60 atmospheres. Calculate using the second virial coefficient. First bit, molar volume of the gas mixture. Second bit, fugacity and fugacity coefficient of nitrogen and benzene. Experimental real coefficient data is B11 is equals to 14, B22 is equals to minus 9.5, B12 is equals to minus 265 centimeter cube per gram. I repeat, a gaseous mixture contains 40 mole percent N2, 60 mole percent benzene at 460 Kelvin and 60 atmospheres. Calculate using the second virial coefficient. First bit is molar volume of the gas mixture. Second bit is fugacity and fugacity coefficient of nitrogen and benzene. Given data is B11 is equals to 14, B22 is equals to minus 9.5, B12 is equals to minus 265 centimeter cube per gram. Now coming to solution. Here we know the compressibility factor expression, that is Z is equals to 1 plus Bp by RT. This is the second virial correlation. Here B is calculated from y1 square b11 plus y2 square b22 plus 2y1 y2 b12. Here y1 y2 are mole fractions and b11 b22 b12 are the virial coefficients data that is already given in our problem. P is the pressure, R is the gas law constant, T is the temperature. After calculating B value, substitute in compressibility factor expression, that is equals to 1 plus minus 128.38 into 60.795 divided by 83.14 into 460. After simplification, we get the value of 0.7959. Z is 0.7959. After calculating Z, we know the ideal gas law. Z is equals to PV by RT. Z already calculated, P given in our problem, R gas law constant, T already given in our problem. From this relation, we have to calculate the volume. Substitute all the values in the expression and calculate. V is 500.691 centimeter cube. After calculating the compressibility factor, we have to calculate the fugacity coefficients. By using the formulas, ln phi1 cap is equals to P by RT, P11 plus Y2 square delta 12. ln phi2 cap is equals to P by RT, B22 plus Y2 square delta 12. After substituting the all values in phi1 cap and phi2 cap expressions, we will get the values of phi1 cap is 0.753, phi2 cap is 0.8925. After getting the values of phi1 cap, substitute in fugacity coefficient expression. Then we have to get the value of F1 cap, that is fugacity. 0.753 is equals to F1 cap by 0.4 into 60.795. Therefore, F1 cap is equals to 18.31. Similarly, we have to calculate the phi2 cap, that is equals to F2 cap by Y2 P. Here given pressure is the 60.795. Therefore, F2 cap is equals to 32.55. In this problem, we have to calculate the compressibility factor initially by using second virial coefficient data and calculate the fugacity coefficient in mixture and calculate the fugacities of mixture. That is binary solution. Now coming to next problem. Estimate the fugacity of liquid 1-butane at 120 degrees centigrade and 34 bar. At 120 degrees centigrade, the vapor pressure is 25.83 bar. Given data here is Tc is equals to 420 Kelvin, Pc is equals to 40.43 bar, Zc is equals to 0.277, Vc is equals to 239.3 centimeter cube per mole. Omega is equals to 0.191. I repeat, estimate the fugacity of liquid 1-butane at 120 degrees centigrade and 34 bar. At 120 degrees centigrade, the vapor pressure is 25.83 bar. Given data is Tc is equals to 420 Kelvin, Pc is equals to 40.43 bar, Zc is equals to 0.277, Vc is equals to 239.3 centimeter cube per mole, omega is equals to 0.191. This data is given in our problem, otherwise we have to get from the tables. Coming to solution. Here, formula required for calculating the liquid fugacity is FL is equals to phi sat into P sat into e power VL into P minus Pi sat by RT. Here, phi is calculated by using ln phi is equals to Vp by RT. Here B is calculated from Bpc by RTC is equals to beta naught plus omega beta dash. Here beta naught and beta dash are the constants. Beta naught and beta dash are calculated from the correlations. Beta naught is equals to 0.083 minus 0.422 divided by Tr power 1.6. Tr power 1.6. Here Tr is the reduced temperature, that is equals to T by Tc. Beta dash is equals to 0.139 minus 0.172 divided by Tr power 4.2. Tr is calculated from Tr is equals to T by Tc. Tc is the critical temperature. Therefore, we have to calculate the Tr, that is equals to 393.15 divided by 420 is equals to 0.936. After getting the value of Tr, substitute in beta naught and beta dash expressions. Then we calculate the beta naught and beta dash value. Beta naught is equals to minus 0.386. Beta dash is equals to minus 0.088. After calculating the beta naught and beta dash, by using the correlation, Bpc by Rtc is equals to beta naught plus omega beta dash. That is equals to B into 40.43 into 10 power 5 divided by 83.14 into 420. That is equals to minus 0.386 plus 0.191 into minus 0.088. After simplification, we get the value of B, that is equals to minus 347.89. After getting the value of B, then we have to calculate the fugacity coefficient. That is ln phi is equals to minus 347.89 into 34 divided by 83.14 into 393.15 Kelvin. ln phi is equals to Bp by RT. B value already calculated, P value, T value already given in our problem, and R value is 83.14, that is in centimeter cube and bar. After simplification, phi I is equals to 0.6968, that is the fugacity coefficient. P value already given in our problem, that is 25.83 bars. Then we have to calculate the liquid volume. From VIL is equals to Vc into Zc power 1 minus Tr power 0.2857. Vc already given in our problem. Zc also given in our problem. Substitute those values and calculate the volume. After getting the volume, we know all the parameters in liquid fugacity expression. Therefore, Fl is equals to 0.6968 into 25.83 into e power 133.27 multiplied with 34 minus 25.83 divided by 83.14 into 393.15. After simplification, we get the value of 18.607 bar. In this given problem, we have to calculate the fugacity. That means liquid fugacity. That is 5 sat into P sat e power V into P minus Pc by RT. Here initially, we have to calculate the fugacity coefficient from Bp by Rt. B is calculated from Bpc by Rtc is equals to beta naught plus omega beta dash. Beta naught and beta dash are the constants. Both are calculated from correlations. After getting the value, we have to calculate the vapor volume, that is equals to VCZC power 1 minus Tr power 0.2857. Then substitute all those values and calculate the fugacity coefficient. Now coming to next problem. Estimate the fugacity of liquid acetone at 110 degrees centigrade and 250 bar. At 110 degrees centigrade, the vapor pressure of the acetone is 4.3 bar and molar volume of saturated liquid acetone is 73 centimeter cube per gram. I repeat, estimate the fugacity of liquid acetone at 110 degrees centigrade and 250 bar. At 110 degrees centigrade, the vapor pressure of acetone is 4.3 bar and molar volume of saturated liquid acetone is 73 centimeter cube per gram. Here also we have to calculate the liquid fugacity. Given data here is Tc is equals to 508.11 Kelvin and Pc is equals to 47 bar. Vi is equals to 73 centimeter cube per gram. Omega is equals to 0.3099. Formula required for calculating liquid fugacity is Fl is equals to 5 sat into P sat into e power VI L into P minus P sat by R. Here phi is calculated from ln phi is equals to Bp by Rt and B is calculated from Bpc by Rtc is equals to beta naught plus omega beta dash. And beta naught and beta dash are calculated from correlations. Beta naught is equals to 0.083 minus 0.422 divided by Tr power 1.6. Beta dash is equals to 0.139 minus 0.172 divided by Tr power 4.2. Here Tr is calculated from T by Tc. Tc is the critical temperature. Now coming to solution. Here Tr is equals to 383.15 divided by 508.11, that is equals to 0.754. Beta naught is equals to 0.083 minus 0.422 divided by 0.754 power 1.6. After simplification, beta naught is equals to minus 0.58. Beta dash is equals to 0.139 minus 0.172 divided by 0.754 power 4.2. After simplification, beta dash is equal to minus 0.424. Then calculate B value. By using Bpc by Rtc is equals to beta naught plus omega beta dash. That is B into 47 by 83.14 into 508.11 is equals to minus 0.58 plus 0.3099 into minus 0.424. After simplification, B value is equals to minus 369.4. ln phi is equals to Vp by Rt. That is minus 639.4 into 250 divided by 83.14 into 383.15. Then simplify the expression. Then we will get the phi value. That is equals to 6.617 into 10 power minus 3. After getting the value of A sat, substitute it fugacity formula. Therefore, FL is equals to 6.617 into 10 power minus 3 into 4.3 into e power 73 into 250 minus 4.3 divided by 83.14 into 383.15. That is 0.0499 bar. After simplification, we get the value of liquid fugacity is equals to 0.0499 bars. Now coming to next problem. The molar volume of a binary mixer at T and P by the expression V is equals to 120x1 plus 70x2 plus 15x1 plus 8x2 into x1 x2. Here, A bit is find the expression for the partial molar volumes of the species 1 and 2 at temperature and pressure. B bit is show that these expressions are continued in accord with equation V is equals to sigma xi Vi bar. The given equation V is recorded. Show that these expressions satisfy Gibbs-Johann equation. I repeat, the molar volume of a binary mixer at T and P by V is equals to 120x1 plus 70x2 plus 15x1 plus 8x2 into x1 x2. A bit. Find the expression for the partial molar volumes of the species 1 and 2 at T and P. B bit is show that these expressions are continued in accord with V is equals to sigma xi Vi bar. The given equation V is recorded. C bit is show that these expressions satisfies Gibbs-Johann equation. And D bit is show that dV1 bar by dx1 at x1 is equals to 1 is equals to dV2 bar by dx1 at x1 is equals to 0 is equals to 0. Coming to solution. Here given V expression is 120x1 plus 70x2 plus 15x1 plus 8x2 into x1 x2. Here we have to substitute x2 with 1 minus x1. After simplifying, V is equals to 50x1 plus 70 plus 7x1 square minus 7x1 cube plus 8x1 minus 8x1 square. Therefore, V is equals to minus 7x1 cube minus x1 square plus 58x1 plus 70. We know the formulas for calculating partial properties for species 1 and species 2. That is, V1 bar is equals to V plus x2 into dV by dx. We already discussed the partial properties in binary mixer. For calculating species 1, the formula is M1 bar is equals to M plus x2 into dm by dx1. V2 bar is equals to V minus x1 dv by dx1 is coming from M2 bar is equals to M minus x1 into dv by dx1. Therefore, differentiate the V expression with respect to x1. That is equals to minus 21x1 square minus 2x1 plus 58. Therefore, V1 bar is equals to minus 7x1 cube minus x1 square plus 58x1 plus 70 into 1 minus x1 into minus 21x1 square minus 2x1 plus 58. After simplification, we will get the value of V1 bar. Similarly, V2 bar is equals to minus 7x1 cube minus x1 square plus 58x1 plus 70 minus x1 into minus 21x1 square minus 2x1 plus 58. After simplification, V2 bar is equals to minus 14x1 cube plus x1 square plus 70. Here we get the values of V1 bar and V2 bar. This is A vector. After calculating V1 bar and V2 bar, coming to V bit. Here we have to calculate total volume. Total volume is equals to sigma xi Vi bar. Total volume is equals to sigma xi Vi bar. That is equals to x1 V1 bar plus x2 V2 bar. Substitute V1 bar and V2 bar values here and simplify. Then we will get the total volume. That is equals to minus 7 x1 cube minus x1 square plus 58 x1 plus 70. Then coming to C bit. That is gives Duhem equation at constant temperature and pressure. That is sigma xi dmi bar is equals to 0. Therefore, x1 dv1 bar by dx1 plus x2 dv2 bar by dx1. Then calculate the dv1 bar by dx1. v1 bar already calculated in A bit. Then differentiate v1 bar with respect to x1. That is equals to 42 x1 square minus 40 x1 minus 2. Similarly, calculate dv2 bar by dx1 equal to 42 x1 square plus 2x. V2 bar already calculated in A bit. In C bit, we have to calculate dv1 bar by dx1, dv2 bar by dx1. Then substitute the x1 dv1 bar by dx1 plus x2 dv2 bar by dx1 is equals to 0. In this bit, mi bar is the general property. We have to substitute with volume because volume is given in our problem. After substituting, we get the value of 0. That is our C bit. Next, coming to D bit. In this bit, we have to calculate the dv1 bar by dx1 at x1 is equals to 1 is equals to 0. Differentiate v1 bar with respect to x1. That is 42 x1 square minus 40 x1 minus 2. Substitute x1 is equals to 1. Then we will get the 0. Similarly, we have to calculate the dv2 bar by dx1 at x1 is equals to 0. Differentiate v2 bar expression with respect to x1. That is equals to 42 x1 square plus 2x. Substitute x1 is with 0. Therefore, we got 0. This is the D. In this problem, they give the expression V and find the partial molar properties by using the formulas and calculate total volume is equals to sigma xi Vi bar. Then show the Gibbs Duhem equation sigma xi dmi bar is equals to 0 and show that dv1 bar by dx1 at x1 is equals to 1 is equals to dv2 bar by dx1 at x1 is equals to 0 is equals to 0.